Okay, so graphing simple rational functions. First things first. A simple rational function is in the form of f of x equals 1 over x. So my denominator is where I'm plugging things in. What can never be in a denominator spot? Zero. So in this, I could never plug 0 in, it would be undefined, it would not work. Which is why this never crosses the x or y axes in this form, okay? Because if I plug because it's not gonna cross over, my vertical asymptote is gonna be x equals 0, and my horizontal asymptote is gonna be y equals 0, because it's not gonna cross over there. If I plug in 1, what do you get out? 1. If I plug in 2, what do you get out? Okay? If I plug in 4, you get 1/4 out, okay? See how this is going. When you are graphing a rational function, you will either have them in quadrants 1 and 3, or you will have them in quadrants 2 and 4. When do you think it goes to 2 and 4? What? When there's a negative, yes. Okay, because it flips it, okay? So, let's talk about graphing this and comparing it with the parent function, okay? If I graph y equals 6 over x, how would I graph that? What would I need to do?
Put numbers for x.
Yeah, put numbers in for x. What type of numbers do you want to put in for x?
Put numbers.
Positives and negatives. I want to put in both, okay? So I would suggest just making a chart again and plugging things in. Let's plug in -3, -2, 1. Can I plug 0 in?
No.
No, -1, 1, 2, and 3. Let's plug these numbers in. I'm gonna run into that graph a little bit. When I plug -3 in, you get what out? What do you get out when you plug? You get what? -2? Yeah. When I plug -2 in, what do you get out? -3. When you plug in -1, what do you get out? When I plug in 1, when you plug in 2, and when you plug in 3. Do you see how this meets and then reverses back out? Okay? So when you do one side, the other side should match with the numbers that you're plugging in. Does that make sense? Yes, Mike.
How do you know what numbers to put on
You
top?
just
Like,
plug in numbers,
whichever, like,
whatever you want.
alright.
But you guys have negative and positive.
You need negatives and positives. You can never plug a 0 into the x when it's only an x in the bottom. Over here, we could plug in a 0. Over here, we can plug in a 0. We'll talk about that, okay? But here, I cannot because it's only an x in the bottom and I can't have a 0 in the bottom, okay? So then we graph this, -3, -2, right? -2, -3, and -1, -6. So my graph, see, I plugged 3 in on each side because I want to see that curve so that I can start connect. I was just always plugging in 3 on each side of your asymptote, okay? So here's this, okay? It looks like that. Now I'm gonna plug in, I have 1, 6, right? I have 2, 3, and I have 3, 2. And once again, it's gonna go like this. Now, when it says compare and contrast, I then need to graph the parent function as well. When I plug in a 1, I get 1 out, right? When you plug in a 2, you get 1/2 out, correct? When I plug in a 3, I get 1/3 out. So it's looking a little bit like this. Yes, it's much more condensed. Okay. When I plug in a -1, I get -1 out. When I plug in a -2, I get -1/2 out and -1/3 out, yes? So how would I write that in written form? How does that compare? What's-
What graph is that for?
That's for the y equals 1 over x, because it says compare with y
You
equals
still
1.
you just plug in the same numbers?
Mm-hmm, plug in the same numbers. What happens there? What do you think's going on? It's what? Okay, but by what? By 6 units. So what's happening? Is it stretching or shrinking? Stretching. Okay, stretching. So you just need to compare and contrast those. So I need it drawn out and I need a little bit of a words so I can understand what's going on. Cool? Okay, that's the simple part, okay? Once again, what is your asymptotes for this? What's your vertical asymptote on this graph, of the green graph? What is it not going to cross? 0. What's your horizontal asymptote of that one? What will it not cross? So horizontal is y equals 0, vertical is x equals 0, okay? Now, when we come over here, we have to talk about domain and range. Domain and range is my vertical and horizontal asymptote. Same thing, okay? They go hand in hand. So if I find the domain, do I have vertical or do I have horizontal asymptote? Vertical, because it would say x equals, right? And so it would be a vertical line. And if I find the range, then I have my horizontal asymptote, okay? So let's talk about how we find those. What would you think we need to do to find those asymptotes? Any ideas? You what? I could graph, but before I graph, I usually want to graph my asymptotes first so that I have my new quadrants so I know where it's going to fit, okay? What do you think? Domain goes with what?
The
X. So where do you think I'm going to look for my domain?
X.
So, yes, it's -2. You take whatever is down here in the denominator spot to find your domain. You set it equal to 0 and you solve for x, no matter what it is. So x cannot equal -2. That's my domain. So I go to -2 and I make a vertical asymptote like this. Because I'm setting up a new quadrant system is what I'm essentially doing. Okay, my quadrants are shifting. Now, where do you think my range comes from?
Y.
Sort of, yes, it is my y, but where does that y usually represent in the equations like these on any type of graphs? It's what? It's the -1, it's what's out here. Wherever's being added or subtracted to. So if there's nothing being added or subtracted, it would be what?
X.
No, if nothing is being added or subtracted, what would that be? What would your horizontal asymptote be if there's nothing being added or subtracted? Zero, yeah, okay. Now, the form that you're seeing this in right here, my range is y cannot equal -1. The form you see this in is called y equals, let me think about this. X minus h plus k. A over x minus h plus k. Yes? H and k are what shifts things, yes? Okay, so your h and your k are your asymptotes. X equals your h asymptote and y equals your k. Remember that h is always opposite of what it is, which is why we set it equal to 0 and solve. So this is my domain and range. It's also my horizontal asymptote, yes? Okay. And it's my vertical. Nope, I mixed that up. Vertical, horizontal. Okay? Now, before I graph, I draw in these lines like this. See how I shifted my quadrants now? So I'm either going to graph here and here, or here and here. Here's why I graph, why I shift those first before I start graphing. Now I know where I need to plug numbers in. I need to plug in numbers on the left of that vertical asymptote and on the right. So now I know what numbers I can choose. Do you get what I'm saying? Does that make sense, Mark? Here I could choose any numbers because 0, 0 was my asymptote. Okay, here I want to choose 3 from this side of that line and 3 from that side of that line. Okay? So I'm going to choose -3, -4, -5. Okay? Actually, let me do this the right way. -5, -4, -3. And over here, I'm going to actually choose -1, 0, and 1. I didn't graph this right, did I? I'm going to choose 0, 1, and 2. Okay, so now we plug these into that equation that's above. You have -4 over x plus 2 minus 1.
No,
If, what?
That was right, it was that the x
No.
is -2.
Oh, the x is -2, thank you. Maybe I'm just going insane right now, I don't know what's wrong with me. Thanks, Chris. Okay, let's plug in things to this x. Let's start with -5. When I plug -5 in, I get -4 over -3, right? So 4/3 minus 1. So negative, or positive third, yes? 4/3 minus 1. 4/3 minus 3/3. Yes. When I plug in -4, I get -4 over -2, which gives me 2 minus 1. When I plug in -3, I get -4 over -1, which gives me -4, yes? Minus, or which gives me positive 4, I'm sorry, -4 over -1 is 4. Minus 1 is 3. Okay. When I plug in -1, I get -4 over 1, so I get -4 minus 1, which is -5. When I plug in 0, because I can plug 0 in on this one, I get -4 divided by 2, which is -2, and -2, -1 is -3. And then when I plug 1 in, I get -4/3 minus 1. So I get -2 1/3, yes? -4/3 is -1 1/3, minus 1 is -2 1/3. Okay, so you have to do a little bit of thinking. Now we graph. -5, 5.
Miss, please, can you use decimals for this fraction?
Yes. -4, 1, and -3, positive 3. Okay, here's what's happening right now. Okay, now, I go to -3, if I go to -1, -5, right? 1, 2, 3, 4, 5. Oh, if I could count, that would help. Okay, then I go to 0, -3, and then I go to 1, -2 1/3. So my graph is looking like this. Yes? Okay, we already stated my domain and my range and my vertical and horizontal asymptote. Beautiful. Cool?
Yep.
Okay, and the reason this is in quadrants 2 and 4 now is why?
Because it was negative,
What's negative?
the thing on the arrow?
Nope. It's because your A,
Oh, yeah,
your constant, is negative, okay? The fraction is technically negative, yes? Okay. Now, let's talk about this one, because this one's a little different. You've got an X up top and an X in the bottom, yes? Okay, so there are some rules when it comes to these. Well, there's some things we need to discuss. This is in the function like this. Y equals AX plus B over X minus H, I believe. No, CX plus D. Over CX plus D. Okay, this is a little bit of a different form. So we're gonna have to decide domain and range. Now, on the other ones, we took the bottom and we set it equal to 0 and solved for domain, correct? And my range was just on the outside. Okay? For this, we've got to first find our vertical and horizontal asymptotes. Here's how you figure this out. Your vertical asymptote always comes from the denominator spot. We're still gonna take x minus 3 set equal to 0, find my vertical asymptote, okay? Still the same thing, vertical is always the denominator. So you get x cannot equal 3, yes? Okay, so I come to 3 and I make my vertical asymptote. Okay? Horizontal asymptote comes from this. There is an x on top, there is an x on bottom, yes? They both have the same power, correct? What power is with both of those x's? 1. If they have the same power, you take it as a fraction. What's the leading coefficient here?
1.
What?
2.
Oh, 2.
2. And what's the leading coefficient in the denominator spot?
1.
So you take 2/1 and that's how you get your horizontal asymptote. Only when there are two x's, one on top and bottom, and they have the same power. Does that make sense? Okay, only when they have the same power do I do that. You take your A over your C. So y cannot equal 2, correct? Okay, so I come over here to 2 and I make my horizontal asymptote. So this is vertical asymptote, this is horizontal asymptote, okay? That's how I always label it, I just put HA and VA. So you're gonna have to start labeling all these things. Okay, now what do you think we do from there? Plug in numbers to the left of that and to the right of my new asymptotes. I'm gonna plug in 2, 0, and -2 because I want to get a little bit of a range, okay? -2, 0, 2 for that side. And then let's see here, what do I want to plug? Let's go ahead and plug in 4, 6, and 8, okay? Just to get a little bit of a range. Now, when I go to plug in, guess what? You have to plug it in 2 spots, yes? Okay, so let's plug in -2 first. When I plug in -2, what's -2 times 2?
-4,
Plus 1?
-3,
Okay, over, what's -2 times to -2 minus 3?
-5.
So you get 3/5, yes? Okay. Now we plug in 0. 2 times 0,
0,
plus 1,
1,
over,
-3.
-1/3. Now we plug in 2. See how fun this is? 2 times 2 is 4, plus 1 is 5, and 2 minus 3 is -1, so -5. Plug in 4. 4 times 2 is 8, plus 1 is 9, and then 9 divided by 1 is just 9, yes? Plug in 6, correct? Is that what I'm going with next? 2 times 6 is 12, 12 plus 1 is 13, and 13 divided by 3 would be 3, 6, 9.
And then be
12.
-9. -9.
Why is it -9?
-6 minus, oh,
It's not -6,
Yeah.
sorry. Okay, so 13 divided by 3 is 4 1/3? Yes, yes, 4 1/3. And then we plug in 8, yes? Okay, 8 times 2 is 16, plus 1 is 17, and 8 minus 3 is 5. 5 goes into 17, 3 and 2/3? Yes,
For 6, is that 5 or 4?
it's 4. 4 1/3. Okay, so then I come over and I graph -2 and 3/5 would be like this. And then 0 and -1/3. And then 2 and -5. Which is beautiful. This is good for us, see? Okay, that means I'm doing something right because they were all in the same section. And then 4, 9 would be like up here, okay? And then 6 and 4/3 would be right about here. And then 8 and 3/2 would be, or 2/3 would be right about there. And there's that graph, yes? Okay, and so now I've told vertical and horizontal asymptote, which is also what? Domain and range. Good. And then I have graphed both segments. And they should have been in quadrants 1 and 3 because this leading coefficient is not negative. Okay, because my A is not negative.
On this,
Yes, ask.
so how like this, like one go down and up, one go up?
They're always gonna do that. They're both facing out. They're not going down and up. This is a whole unit. It's almost like a
So
U.
So that one is like the points that are just down there?
This is the points that are 4, 6, and 8 on this side of the asymptote. This one is what's on this side of the asymptote. The asymptote is where it can't cross. So if this graph had no asymptotes, those would connect. Those dots would all connect. But it has a breaking point because it's a fraction. And I can't have zero in a denominator for a fraction? And what else can't I have in a fraction, like in the denominator spot? What do you think I can't have? It's a bit of a tricky question. Can you have negatives? Yes.
Oh,
Can you
yes.
have positives?
Yeah.
Can't have zero. What would be the other unit of measure we've talked?
Imaginary?
Imaginary.
Like radicals.
Yeah. That's why I have asymptotes and breaks in my graph.
Mm.
Okay?